Okay, welcome everyone to this webinar, which is the 8th and last webinar in a series of webinars that Meridian has been hosting on the topic of data management. So 4 of these we ran those in June 2020, and the last 4 webinars have been running here in September 2020. And today it is Sarah Vela, data manager at Meridian, who will be running the webinar. And today's topic is dirty data. And with that very short introduction, I'll pass on the mic to you, Sarah, and the floor is yours.
All right. So let me share my screen. Come on. No. All right, so everyone can see the presentation. There are features in Zoom to ask questions and raise your hand, but it's a little inconsistent as to what I can see. So I'm sure Oliver will let me know if anything pops up. But otherwise, we'll just start going through things. So today we're going to be doing a presentation on what's called dirty data. What's happening here? Yeah. So our general schedule for this is for about the first 45 minutes, I'm going to go through this presentation, which is going to go over trying to explain what we mean by dirty data and why it's significant, and then present a model that I tend to use for trying to evaluate whether data is dirty. Then we're going to take about a 15-minute break to give you guys a chance to go to the bathroom and stretch your legs, and then we're going to start kind of a more hands-on section. And exactly what that's going to look like is going to depend on kind of what the participants want to do. If you guys have brought data, if you have questions that you want to talk about, we're definitely going to start by just looking at a sample data set that I'll provide you a link to. And you can look through a little bit, and then we'll discuss some of the things that we've gone over in the presentation and how they show up in that data set. And then we can either look at additional just open data sets and do the same sort of thing, or if people have specific data sets that they want to share or that they want to ask questions about, then we can try and figure out getting those up on screen, and we can go through those. If there are more general questions, we kind of left a half hour at the end. This is scheduled to go till 3:30 for more general discussion and questions, but we may end up not needing that time. So that being said, let's dive into things. Okay, so what is dirty data? Or perhaps more accurately, what is dirty data and why should you care? So if people have been attending these workshop series, or if you've been paying any attention, or really you just saw this and thought that's something I'd like to go to, then I probably don't have to explain to you that data is valuable. Data is an asset. And like other very valuable things, for example, money or property, it is going to be most valuable if it's kept in kind of good condition. If it's well maintained and it's as good as it can be. So if you'll forgive a slightly labored metaphor to try and explain this comparison, let's say in the 1970s in mafia style, you stuffed $1,000 under your mattress. And you thought, this will be safe, I'll know where it is, I know it'll be there when I need it. This is perfectly fine. Now you're not wrong, it's still $1,000. It's still stuffed under the mattress. You can still pull those bills out and exchange them for goods and services, but that's not really the same as putting that $1,000 in a bank in the 1970s and then sort of letting it sit there and accrue. Putting it under that sort of maintenance, if you will, or kind of putting it in a system where it can be looked after, does a couple of things. It would allow you to earn interest on that money. So basically you give it to the bank loans it out to other people, those people pay interest on what they're paying, the bank pays you back a little bit of interest. That's how it works with money. Data is a similar thing. You can share it with other people and reap rewards through sharing it, whether it is that you, on a goodwill sense, you put through work collecting that data and now you get to see it do good in the world. If it's that you get a data citation out of it so that you can, kind of put that on your CV that people are using your data. There's a lot of things that you can get back by having it in a way that allows it to be used by other people. If you put money in a bank, it doesn't age in the same way. So eventually, if you've got a bunch of bills from the 1970s under your mattress you're slowly pulling out, you're going to reach the point where people are going to start asking where you got this very old bill. In a similar sort of way, if your data is on an old, like, you know, those big black 6-inch floppy disks, at some point people are going to start questioning where you got that and why you still have it. Having data in a place and under a system where it's kind of being maintained allows it to keep up to date. You can transfer it through as technology changes, whether that's hardware or just file formats. You can check it and make sure that it's not being degraded, it's not breaking down in any way. It just means that it's going to stick around for longer. If you put money in a bank, it's also somewhat less likely to go missing, or if it goes missing, there'll be a better account of exactly what happened to it, who's touched it, who moved it around, when did it happen, those sorts of things. You can actually have a statement that of kind of metadata around it that helps you know what happened to it. So in a similar way, if your data is just sitting somewhere, people might borrow it, and then that person can hand it on to someone else. All of these sorts of things, it just kind of gets out of hand. It can also just go missing or become corrupt. If you're keeping it in a way where you're perhaps registering who's requested it, you know who got it, you know who still has it, when they took it, and if things start to go wrong, it's at least possible to track back where it kind of ended up. So that's all to say that basically data is valuable, but the value of data is going to drop pretty quickly if it's of low quality, if it's dirty, or if it's not very easy to work with. If it's is of low quality, then it's going to be harder to find because people might be searching for terms that aren't accurate to what's in the data. It's going to be more difficult to work with if people run an analysis and there's blanks or things that are wrong, as we'll go over in a little bit. Then that's going to affect their ability to do analysis, or they might have to clean the data themselves before they can use it. If you do have multiple people who are cleaning data and they're cleaning it in different ways, then you end up with this idea of the data being unreliable or unpredictable, because basically someone cleans it one way and runs an analysis, and someone else cleans it a different way and runs the same analysis, but they end up with different results. And they are probably going to look at the data and say that the data is the problem with that. It's not clean enough to be kind of reliable. And as a result, dirty data is therefore less able to support any kind of, whether it's a research conclusion you're trying to make, if you're more of an organization trying to use data to make a decision, the less reliable that data seems, the harder it's going to be to use that data to back up what you're doing. So to summarize all that, if you want to maximize the value of data, then you really need to be investing in its quality and making sure that it's as clean and good as it can be. And that involves both looking at data that you already have and evaluating and cleaning those to make them as good as possible, and then planning ahead when you go to collect new data to try and make sure that it's clean when it comes in and you just don't need to worry about these things. And we're going to talk through kind of both aspects of that as we go through this presentation. All right, so I'm sure everyone was thoroughly convinced by that. So I think it just leaves the basic question of, okay, what is dirty data? I'm on about all of these things around why it's bad, but what is it? Okay. Evaluating data is sort of a practice thing. It's a tacit knowledge thing. Eventually you just, you know it when you see it, by which I mean literally you've probably worked with a data set before, tried to run an analysis, realized that there was something wrong in the data that was unclean in some way that caused a problem. And now when you open up a data set, you know to check for that one because it caused a problem before. And if you do that enough times as a data manager, you kind of just learn to look at a data set and be like, this is going to work, or this one's going to take a lot of time. It also doesn't help that most of the quirks of what makes data dirty or clean is sort of specific to the data set. So there's a lot of things that it's difficult to talk through specifics. That's why we sort of left time. If people want to go over the specifics of their data set, we can definitely do that in the second half. But most of what I can talk about in the presentation is going to be these common issues that tend to crop up all over the time, or all over the place, so that you kind of know to check for those. You can at least catch the sort of low-hanging common ones. Okay, so to present that, this is a model that I use, that I've come up with. It is by far not the only one. There's all sorts of ways out there that you can look up to figure out how to evaluate data. But this is a model I call the 3 C's. So is the data complete? Is it correct? And is it consistent? And we're going to go through each of these in order. I do want to briefly stop. Just Oliver, can you let me know that everything's still good?
Yeah, all good.
Perfect, thank you. Okay, diving in here. So starting with complete. All right, so complete is basically asking the question, is all the necessary data present? So let's preface this by saying that I am a data manager, and most of the data that I work with is in this sort of like tabular mixes of numbers and sort of text. So I've kind of reflected that in the examples that I'm using in this presentation, because I think that they're the easiest to put up on a screen and talk through and have people understand. If you're someone where your data is more things that are popping out the back of sort of a computer, it's all very number-based, or you're dropping, say, hydrophones in water and collecting the data from that, most of what I'm talking about will still apply. You'll just kind of need to abstract it a little bit. And again, we can definitely dive into that more specifically after we come back from our break. Okay, so is all the data necessary data present? So let's assume that this was your sample data set and you're trying to figure out whether or not it's complete. So the first dynamic of this is, I think, fairly obvious, which is if you're talking about tabular data and you have holes in it, you can usually pick those up. Those could just be blanks. It could say null or NA, but basically it's not real data. It's not actually giving you any information. That would be a sign that this data set has at least some incompletion in it. Other facets to consider, though, are, have you gotten all the expected records or rows? Is all of the sort of volume of data that you expected to be there or need actually there? And that could be either, were there more days that you would have liked to have collected data, or more people that you would have liked to get it from and you just were unable to? Or if you are using somebody's secondary data, were they unable to do that? Did they not provide them? This particularly raises questions around, if there is data missing in terms of sort of additional rows, are there also biases in the rows that you've gotten that you need to consider? So for example, these ones are all centered in the Atlantic provinces. If you were trying to do something that was Canada-wide, you're probably missing rows of data, or this data set is just too small to work for you. Going the other direction, you also need to consider the sort of dimension of columns if you're in a spreadsheet, or additional fields of data. So this is a fine data set in and of itself, but if you were really hoping to email people on this list and they didn't provide email address as a field, it's not a particularly useful data set for you. And of course, that could be built out infinitely, not just in terms of columns, but perhaps if you're in more of a structure that needs a database, or et cetera. Basically just thinking about the sheer volume of data. How much information do you need about each thing? How many things should there be? Do you have all of the information about each thing? Would be the three dimensions of the concept of complete. Now, as I hinted, whether any of those gaps are significant, do they actually mean that the data is incomplete or problematically incomplete, depends on what you're planning to use it for. Depending on your research question or the system that you're trying to put the data into, or whatever it is that you're trying to do with it, whether there's a missing email address, whether, so for example, up on this one, if your intention is to do an average of the ages, there's a missing age, that might be a problem unless you come up with a rule to avoid it. But if you don't actually need that, if all you really needed were the people's names and where they lived, then the fact that there's a hole there is irrelevant to you. Yeah, so when you're evaluating it, you need to bounce off the data from the questions that you're asking, which as a data manager is really difficult when I don't have a concrete question. I'm trying to anticipate what other people's questions are going to be, and then trying to figure out whether the data is complete enough for that. So once we evaluate that, what do we sort of do about it in very general terms? We'll go into more specifics at the end of this presentation, but basically if you have a living data set, so a data set that's still being added to, then this is something you can address over time. You can make it more complete. You can start collecting additional data in terms of rows every time a new one comes in. You can choose to add new fields so that as those new records come in, you're sort of getting additional things along that column dimension. But do note that if you start doing that, you're going to increase the number of holes in the records that already existed. So in a living sense, in a living data set, you can kind of increase completeness over time. but not necessarily 100% completion unless you're really able to go back and fill in any gaps that you might have already had, which is often not possible. If you have a static data set, which is to say that one that was collected years ago, or where you're just not interested in doing any more collection, it's just kind of there, you're obviously less able to affect how complete it is. It just is the volume of data that's there is what you have. But you can at least still evaluate and kind of describe the data as you're making it available to other people, or just writing down notes for yourself for your own future use that remind you or explain to other people where the limitations of completeness are, so that they know before they download it or when they go to do analysis that these are things they're going to hit. They need to come up with a solution for gaps in the age column because not everyone provided it. And that's just sort of a helpful thing so that people know that you've done this analysis and can be fairly confident that, you know, at least they understand where the data is incomplete if it's not complete. And that is our first C. Okay. Going on to our second one here. So is the data correct? So this is about, is it reliable? Is it error-free? Is it up-to-date? Can people trust it? And this is something that's really hard to guarantee. You know, everything is ultimately subjective in some way, or a lot of things that end up in data are subjective. Even if you're talking about a reading that comes out of a hydrophone, you might have questions about whether it was calibrated, whether it was, you know, the proper procedure was followed when it was put in the water. It's very difficult to just look at data and really guarantee that it is correct. In particular, it's difficult if you're just having people submit it without it being checked or controlled in any way. But monitoring data is very, very expensive. So for example, there's always a lot of pressure on groups like Facebook or other major social media, Twitter, to be doing monitoring, to be checking things as they come in and make sure that they meet some sort of standards. They're not misleading, they're not against any particular groups, that sort of thing. And they try, they put money into that. They have people that are supposed to be monitoring things, but it's really not a practical thing to do. The sheer volume of data that they're working with means that unless everyone on the planet is going to go work for Facebook and just be checking everyone else's messages as they come in, you're not really able to monitor it all that closely or all that accurately. If you're a very small research group, which has basically no excess money to be putting in any sort of monitoring place, especially if you're collecting data from the general masses online, you're going to be even less able to do this, to be checking every record as it comes in. But that doesn't mean that you want to give up on that entirely. I think it's about prioritizing preventable and obvious errors, things that you can check without a whole lot of oversight, or that you can kind of check once a month and just make sure that you're purging records or fixing records that have issues, so that even if your ability to check this is limited, you can still do something. So here's a sort of list of those types of errors that I'm talking about, the kind of common classes of errors, if you will. So you've got just genuine mistakes where people have had typos, or they've tried to copy something off of another source and just had an issue where they flipped a number around. You can have things that are misunderstandings, where you either failed to provide instruction, or the instruction you provided wasn't clear enough and they tried to answer but answered incorrectly. They didn't give you the information that you were actually looking for in whatever field it was you were asking people to fill out. People might provide partial answers, where either they didn't understand what was important details, or how much time they should be putting into this, or why it mattered. So they'll provide some sort of answer, but it's not everything that they could have given you. So it's not as correct as it could be. Untimeliness is, especially if you're talking about things like phone numbers, emails, addresses. People move, people get married, things change on a day-to-day basis, particularly connected to people, though not exclusively to people, that if it's not updated in the data, over time it's just going to become incorrect because it's fallen out of state with reality. It was right when it was submitted, but it's not right anymore. You can also find the data has become incorrect because there has been data loss. If something didn't save, something gets deleted, something does get corrupted because it's not being checked or maintained. And the next time that you go to open it, there's either the wrong value, a completely unreadable value. it's not really a blank. You know, there was data there originally. It's just sort of been lost, and now you have a correction issue. If you're collecting things online, you also have the risk of like this purposeful garbage data where people with nothing better to do, I suppose, just decide that they want to try and take down a system or overwhelm it with data that is complete garbage. They just write a bot to do it. And checking for that sort of thing and getting rid of those records is also very helpful. So that's our second C, correct? And our last one here is it consistent? So will the data support analysis, or are there things in it that you maybe can't be sure what it's saying because it's not consistent enough? So if we look at this example here, everyone's kind of got a purposeful different form of inconsistency in it. So under the name one, if you attended the last Tuesday workshop, the first one of this series, I talked a lot about something called person disambiguation, which is the idea that people will record their names in lots of ways over time, or lots of different ways in different places, and trying to refigure out afterwards whether or not that is in fact the same person. So in this case, are these 3 rows the same person or not? It's ambiguous. We don't really know based on that. They could be. They could also be 3 completely different people, or any 2 could be the same person. So that's the sort of thing where allowing people to enter free text for something like a name, as opposed to, say, having them log in and then just connecting that to their user account, is a much less ambiguous way to connect data to a particular person. If we're looking at the location and phone columns on here, so then we've gotten into just different formats of putting that. All of them are equally accurate. It's just a convention of, do you just want the city? Do you just want the province? Do you want them both? Do you want it all spelled out? Are abbreviations okay? If you've not provided instruction or controls on any of this, then people are just going to submit in the way that makes the most sense to them. And if you're then trying to, say, make a pie chart out of this, you're going to end up with a whole lot of columns because, or a whole lot of segments, because people have filled it out in slightly different ways. The phone number, similarly, if you need to be able to put these up in a certain way to make them, actually clickable to dial a phone number, it may matter whether people have included brackets, whether people have included dashes, sort of how they've put that thing in. Number of pets, so someone's chosen to write it out as a word, someone's chosen to put it in as a number. If you were hoping to run an average of this or any sort of statistical analysis, the problem with them writing it in as 3 is it's just going to see that as a string. No one's going to know what to do with that until you've cleaned it up. And then again, with the favorite color, the concept of if you don't provide options, people will really pick what makes most sense to them. They'll just free write in anything, which may or may not be what you want, depending on the analysis that you're trying to do. So this is probably the thing that's the most fixable. If you have a data set that you think is quite dirty, it's really hard to fix that correct thing or to do the complete thing if you can't go back and get more data, but you can almost always make data more consistent. The problem is you may not want to, and this is where we'll get into it. So if you know in advance that you want to make sure your data is really consistent, you can set it up to make sure that at the moment it's collected, it gets cleaned up. Either through controls on an interface or through it being just programmatically, you've got a little program in the background, or I say program. This program could be a human who reviews it as it comes in, basically, and just fixes these errors. But they see that number 3 and they know to switch that out to the actual digit 3. Those little changes, things like that, easy to fix that as it's coming in. And again, that's the part of data maintenance. So if you are checking on your data kind of once a month, just to make sure that it's still in good state, nothing's gone wrong with it, or once every 3 months, 6 months, also taking a look at these sorts of things and then building in cleaning those over time. And we can talk about some tools that will let you do that in a way that's a little bit more click button. But basically building into any sort of data maintenance pipeline that you do clean it and make things more consistent. You can also leave cleaning up to the end user, either clean it as you pass it to them. So if you're going to send someone a CSV or they're going to download it off of a website, ensuring that what they're given is a clean copy, even if you want to keep your copy as whatever the original was, is a possible thing. So cleaning it as it goes out the door, programmatically or manually. Or you might allow them to clean it, though, as we talked about in wow, which section was that in? As we talked about earlier, the risks of letting end users clean data is that they may not clean it in the same way. So those are all things that are very possible. The balance you want to have in that is, once you have clean data, if you change that word 3 to the digit 3 and then click save, you have lost the original thing that was entered was the word 3. And whether or not that is ever going to be a significant point for you is, again, entirely dependent on what you're doing with the data and what people down the line might want to do with the data. If you suddenly decide that you'd like to run an analysis on what percentage of people see the need to put in a number and choose to put it in as a word rather than a digit, maybe that is useful. If you're just looking at doing an average of how many pets people have, you could probably just change it to a number. But that really is often one-way path, unless you're going to do with like data duplication. So you basically have a raw copy and your working copy and your colleague's working copy, which might be different, which is going to also introduce its own fun in terms of keeping track of those things and what's been cleaned and where all these copies have ended up. Pausing again to make sure that nothing's on fire in the background, Oliver.
That's all good, yeah.
Okay. All right, so if we kind of accept that as a general model of things to be considering, how do we actually work with that? What do we do with it? So I've put together some tips or models of things that we can do. If anyone has anything that they've tried or that they've used to address these or related issues that you want to share, by all means, speak up or click the raise your hand button and I'll check in at some point here. But as we go through these, I've kind of presented, as I say, 2 scenarios. So the assumption that you are doing a new data collection effort and you want to try and make sure that you're getting as clean of data as possible from square one. And then also the idea that you already have an existing data set that you want to try and clean up. So I've tried to talk through a couple of ways that you can address the issues we covered for each of those scenarios. And there's often some of the things that you can do are very similar, but we'll go through here. So how do you improve the completeness of your data set? If you're at that collection point, if we're assuming that you have some sort of web form survey, at some point, whether it's the random population or specifically people on your team, people are entering data somewhere. It could be directly into a spreadsheet, who knows? So at that point, what you want to consider are what are the fields that should be mandatory in that? Whether you've made a spreadsheet and you kind of set the column headers, or you've made a web form and it's these actual sorts of fields, thinking through in that, what are the ones that they should not be able to click submit or to click save unless that information has been submitted? That should be absolutely mandatory data sets, and which ones are ones that don't really matter all that much. That if there is a blank in there, at least for the purposes that you conceive of using your data for, it's fine. And the reason you don't just want to make everything mandatory, as tempting as that would be, is if it's too onerous to fill out a data set, if there are too many fields and too much complication, you'll start to lose rows because people just won't fill it out. So it's that balance of wanting as many kind of columns as you can, so you get as rich a data set as you need, without losing numbers of rows because people stop filling it out. And then finding that balance point within that to make sure that there's as few blanks as possible. So for something like the example put here, the idea that there's a single field and a checkbox that's basically mandatory on this. It won't let you submit it until you fill out your address. Not overly onerous, especially if that's something that's sort of necessary. On something like Meridian is building a data discovery portal where people can go in and describe their data. There's about 7 tabs of metadata you can potentially fill in. Most of it is optional, because if we presented people with that many fields and said you must fill in all of these, we would get no one who wanted to do it. So it is a balancing act in trying to figure out how best to ensure completeness without affecting a different form of completeness. Okay, if you have a pre-existing data set, as we talked about, it's somewhat difficult to really improve your completeness unless you are kind of like re-enter and reinvest in making this work. Which is to say, if we go back to kind of the example data set that I'd provided for this, you have a simple list of names and some phone numbers, but some of the phone numbers are missing. If you're in the context of, say, an office building where you could walk over to the person's desk and be like, hey, you didn't fill out your phone number, can I get that from you now? It's possible to keep filling it out to kind of improve that over time. In a lot of cases, if you're talking about something that happened on a particular day, you went out and you dropped that hydrophone in the water, it's no longer that day. You kind of can't get that data set, that's lost. There is another aspect, though, of how you can kind of bulk up data sets or improve their completeness, which is combining them across data sets that you might have access to. So if you, which one to stick with you? Let's do both. So if you are somebody who works in an office and you're collecting data about employees, and you happen to know that there's also a data set that connects those employees to, let's say, their performance on the company volleyball team. You can start building out columns just by connecting those data sets together. Is that a silly example? Yes, but you see what I'm saying. If there are multiple data sets that you have access to that are about the same thing, you can increase the completeness of all of them by connecting them together. And the way you do that is by removing that sort of ambiguity piece of, they're all just listed by name. Is this the same person? Is it not? If things are more connected by an ID, whether it was, say, an employee ID or something that was assigned as part of a study, the ability to bulk that out and connect multiple data sets together means that what you end up with is a much more complete picture. This introduces a lot of privacy concerns. If the data is coming from different sources or has different people who are allowed to see it. For example, you wouldn't want to combine, say, your company's employee data with their medical histories. That's probably going to cause some problems the next time that someone needs a phone list from HR. But within specific examples that the data you have is amenable to that, it's something to consider. All right, how do we improve the correctness of data? So again, at that point of collection, privileging drop-down fields or things that will give you a bit of autocomplete over just free text that let people type things in will prevent those typos, will prevent some of that inconsistent language, will let you have more concrete categories that people are picking from so that everything kind of looks more consistent as well. I think we'll go over that in the next one too. It also limits like that garbage data question or places where people are trying to purposely put in bad data. This makes it less clear if it is garbage. I have the wrong tone of voice for this. This is supposed to be a caveat. Using a lot of drop-down fields, if you're sort of limiting free text, especially if you're eliminating free text, means that it's very difficult to look at a data set and figure out whether it was a bunch of bots that filled it out, because the data will look normal. It'll all match because it all came down from pre-selected values. Which brings us to the second point of this, of implementing that automated or manual review of data as it is coming in. So there are an increasing number of tools and options out there, whether you're looking at something like Bootstrap, if people are familiar with that for interface, or just libraries that are built into anything that's being programmed, Excel macros, even if you want to go that way. People are really building and putting things out there that will help you check whether the data you are getting is what you expected to be getting. And you get these systems set up, and basically every time someone goes to submit, it will do that thing where it pops up the red boxes and goes, hey, wait, you didn't fill this out, or this doesn't look like it's the format I'm expecting. I'm expecting a number and you've put in a word, or those sorts of questions. To a degree, that can be done automatically more and more now. There is also always that room, if you have the budget or the staff to implement a process for reviewing that stuff manually, that, on a nightly basis or weekly, monthly, whatever it is that you can manage to do, someone's actually reflecting back on that data and making sure that nothing's going wrong, and that if things are going wrong, you are addressing them. Either cleaning the data itself or changing the way that it's being collected to make sure that those issues aren't persisting. If you want to improve the correctness of pre-existing data, again, it can be really hard to tell that it's even wrong, let alone what the correct answer is, unless you're going back and basically recollecting. But a couple things you can do is attach an expiration date to a data set or to a row in a data set that basically says this is the last time that this was updated. And our standard is it will be considered accurate for 18 months or 2 years, depending on what it is. And then you should start to wonder whether or not that is actually still accurate. Just so people kind of have a frame of reference of how old is this data. The other really important thing for correctness, I would argue maybe the most important thing you can do, especially if you are someone who is sharing data on a regular basis, or if you're an organization that sort of gives out data frequently, is to have an error remediation process. So if someone takes some of your data or is looking online and finds something and realizes that something is wrong, sees that there's a typo here, or this is incorrect, or this is out of date, and out of the interest of communal good decides to let you know that, what do you do with that information? Do you have a process by which you can note that that's even been recorded, that someone's pointed that out? Do you have a way to fix it in the data sets, or to flag it so that you're not continually getting that note, so at least people know when they download it, we can't fix it centrally because maybe there's a legacy issue that will prevent you from fixing it, but you should know, new user of this data, that you might want to correct this field for your own use going forward. My favorite example of this being done really badly was at a university I worked at that will remain unnamed, where every single year they would do the faculty performance reviews, and they would send them a little package from the sort of registrar's office that listed out all of the courses that they taught and all of the people that they were supervising as graduate students, and kind of just like a good statistical printout of their activities as the university understood them. And then they would take that for their performance review. And for 12 years running, apparently, a prof emailed the registrar's office after getting this every single year and told them that it was an incorrect thing in it. They had never supervised this graduate student. They'd never met them in their life. And they let them know every single year, and they never fixed it, so that every year it would come out again, and they'd have to manually fix it on their own record before they took it to their manager, or their dean rather, to do their performance review. And that's the sort of thing when I hear it, when I go, okay, that person happened to know that that data was incorrect, and they tried to get it fixed even though it wasn't. How much other data in there is incorrect that other people never caught, or the person who did catch it let them know but they never fixed it and other people don't know? If you start to know that like any kind of one or two significant things are wrong in a data set, at least for me as a data manager, my faith in the entire data set becomes questioned. So yeah, basically if you take one thing away from this and it's the only thing that you can implement, figure out what you're going to do if people point out that something in your data is wrong. And the thing you do should not just be get offended, because I've seen a lot of that as well. People are genuinely trying to be helpful. But yes, error remediation processes, very rarely done well. Okay, and our last one here as we come into the break with a few slides is about improving consistency. So similar to having drop-down fields, I'm sorry, I'm getting a phone call. Sorry. Similar to having drop-down fields, you can also have auto-formatted fields. So if you've ever gone to a website and just typed in your phone number, and then when you click out of the box, suddenly it's in brackets and with dashes, that's where they've built a little thing in the background that just auto-formats it to what they want it to be, so that everyone's is always consistent. in a similar way, having controlled vocabularies. So if you look back at our example where people were listing off their favorite colors and basically just putting in a completely free text, whatever color they could think of, even if in fact it wasn't a color, it would have been an option. You can instead kind of pre-think what are the options that we want to have available to come up with a controlled vocabulary, and then either put it in a dropdown so that you're limiting it in that way. Or you can do, if you're thinking something more like, say, keywords. One second, guys. I'm so sorry. I do need to mute here to deal with a phone call.
Okay, sounds like we have a little break now, but I'm expecting that Sarah will be back shortly. So please hang on, and hopefully we'll have her back in just a few moments.
So sorry, guys. My phone would not stop ringing, and it wasn't even actually all that important. But I've got, I think, 2 slides left here, so let's just very quickly get through this, and then we will go to break. So yes, just to finish this up. If you are dealing with something like keywords or things where you want people to have the ability to input free text, but ideally you'd still like to have a restricted number of values. So you don't want something like, I can't think of any word in the world right now. If you didn't want keywords to come up as, say, singular versus plural versions, or just really close terms, you can have something that's called suggested values, where when you start typing a word in, it will then pop up suggestions of things that are already in the system, and then you can click on those and be like, oh yeah, that's what I was looking for, that's close enough. So this is the thing that it relies on an aspect of human psychology, which is that people like to think that they're snowflakes. They like to think that their situation is definitely unique, but they're also really lazy. So they like the freedom of being able to type in free text, but if they then see something where, oh, I only have to type 3 letters rather than 7, and now I can click, they'll tend to do that. So it kind of gives you the best balance of making sure that people are able to give the answer they'd like to give, but if someone's given a similar answer, they'll often just go with that answer. And it's just a way to balance out getting complete data, but that's as consistent as it needs to be. So that's if you're collecting new data. If you've got sort of a pre-existing data set and you want to improve how consistent that is, as we said, that's actually pretty easy to do. You just kind of can go back through and fix it and massage it into, you know, if you've established a controlled vocabulary, but not until after the fact, go through and massage it into that controlled vocabulary. Anything that's in a family of red colors now just becomes red. And there's a couple ways that you can do that. So you can do it in the actual data store. So you could open up the Excel files and just change them in there, or open up the database and just actually change the value in the database. You can write a script that basically the data exists as it is when it's in storage, but whenever it gets put out for someone to use it, it will be programmatically cleaned so that it just becomes that. And if you're looking to do something like that on like a repeated basis, then the one tool I do want to highlight that I think is, you know, pretty easy to use for anyone, even if you are not tech savvy, is called OpenRefine. Now, when this was developed, it was a Google product. I'm not 100% sure if they're still the ones that are doing it or not, but it's basically a tool in which you go in, you can upload CSVs or Excel files, and then tell it, I want you to go through this file and do kind of a pattern match thing. But it's the same sort of thing you would do if you were writing it programmatically, but instead of needing to know how to write regular expressions and what all those crazy symbols means, it lets you do it in a more select from a list. I want, just describe it in human sense. This is what I want it to do. And then the tool just does it to the data. We're not gonna like actually look at that today. I'm not going to open it up or like give a demo of it or anything, but I would definitely note it as something to look into if you have a lot of data sets that need to be cleaned in a similar way. All right, so with that, we will go to break. I am going to drop a link in the chat that people can access as they kind of get back or as you're drinking your coffee, whatever it is you're doing. And that'll be the data set that we're going to start going over when we get back from break as kind of an example. There's not any questions going into this.
Okay. And just to confirm, Sarah, the break will be 13 minutes maybe now, so till
just after, a little after
2 o'clock Halifax time.
Yeah.
I guess 2:30 if you're in Newfoundland. Okay, so we'll be back in 12, 13 minutes. Sarah, are you back in front of the computer and ready to start the second session?
Yep.
Okay, it's 2 o'clock on my watch, so I think we can start.
Sure. So I will share my screen again, but I dropped a link in the chat if anyone wants to kind of download the data set and play along themselves. All right. So the data set I picked to look at somewhat arbitrarily is about the escape of sort of like farm grown fish in BC, I believe, which, as I say, was kind of completely arbitrarily chosen. Fish based because Meridian, basically. Keep it somewhat close to the topic that we look at in general. But otherwise, it was just clicking through a few and trying to find one that I thought had some good examples of some of the things that I've talked about. So I think what I'm going to do for this one is just kind of walk through how I approach this. It's a nice small data set, how we kind of looked at it, and then we can either talk about this one if there are other things that people are seeing and you want to comment on. If anyone's got a data set that they want to look at, we can try and find another data set online. I'm kind of trying to keep this as open as possible so that we can try and tailor to who's here and what they're looking for to have it be as useful as possible. And if that means that we just kind of wrap things up really early because the presentation told you everything that you needed to know, then that's fine by me too. But all right, so we'll start with this. So if you follow the link and then click on, there's sort of a list of different files associated with this, but we're looking at the actual data set and the English one, unless you would prefer to work in the French, though I can't speak to whether it looks any different. Download it, open it up, and this is what you should see in Excel. So the first thing is it warning up here that this is a CSV, not an Excel, and therefore if you're coloring anything, it's not going to save it, those sorts of things, but that's fine for our purposes. So in general, as a data manager, the first thing I would do opening a new data set is to kind of select it all and throw a filter on it. If you're not familiar with Excel, then that's just an option that's under the data tab. And it kind of puts one of these little arrows on the top of each column that will kind of let you search through it, filter through it, give you some different options for looking at it. And we'll use those to effect in a second here. But let's maybe work in the order that I went through in the presentation. So the first thing we want to assess is, does this data set seem to be complete? So given the number of kind of NAs plugged into various columns in different ones here, I think we could safely say that it's not certainly 100% complete. There were fields that people didn't bother to figure out that may or may not affect what you can do with this data and how accurate any analysis you're doing with it is going to be. In terms of the other dimensions, if you recall, I mentioned that this is about the government tracking basically fish farms that have lost fish, have released them accidentally into the wild, and whether or not they managed to get them back, or what they did to try and prevent it from happening again. It seems like the sort of topic where there's probably missing data in terms of rows, either because people didn't notice that things happened, or maybe didn't report that it happened because they figured they got it fixed fast enough that it didn't matter, and why bother with that paperwork. So just based on sort of the logic of what the data is, I would be a little bit speculative about whether or not this is truly all of the times that something has happened, or if it's just all the times that it was reported. And then of course, going up the other way, there's any number of fields that might be missing from this, depending on what it is that you hope to do with it. Looking across it, I mean, you'd certainly be able to like basically map things and maybe have like a little, here's how good or bad it is. But if you really wanted to know, without having to throw it into, say, Google Maps, where this is, what province, what city, what kind of exact location, they don't really tell you that. They don't have like a location name field. So something like that might be useful. Again, the column ones is difficult to talk about because it's so specific on what question you're asking. But in terms of completeness, we can see that there are some at least minor issues that you would need to deal with. You would probably need to explain in any sort of analysis that it's unclear whether this is actually all of the times, all of the escapes that have happened. And you'd have to justify what it is that you did where these NAs appear to work with that data. On to whether it's correct or not. The major error that I noted, which makes me slightly concerned, there were two longitude up in here where they've missed the negative sign at the beginning, which is one of those things that's just kind of a typo or a transcription error, or whoever put it in didn't understand that the negative was a necessary part of a longitude. But if you actually went to map those, it means that those two escapes happened in mainland China. And I don't know why the Canadian government was tracking fish escaping in mainland China, other than that there was a typo. But it's one of those things that if you don't look at the data set and you just kind of run it through a program that maps it, you're going to realize that there's a couple that are on the opposite side of the world to where they're supposed to be. And then you'll be back in the data trying to figure out why it is that your map looks like that. In terms of correctness, the other one that jumped out to me was there's this field that is the cause of escape event, which from the options that are in here is one of those cases where I think they provided a controlled vocabulary, maybe like a little checklist or just sort of select multiple ones from this list that let them very quickly explain what it is that happened that caused the fish to escape. And that's great for, say, making this into a pie chart, because now if you want to see how many were caused by a hole in the net caused by equipment, it's going to be pretty easy to see that section of a pie chart because this is a nice consistent data set. But it doesn't necessarily tell you what was the equipment, how big was the hole, what actually happened, did someone drive the equipment into the net? Things like that. So it's one of those things where this is correct and it's consistent, but it's not necessarily the most correct that it could be, or it's not all of the information that you could have gotten. And whether it's sufficient or not, again, what questions are we asking? What are we trying to do with it? So the last one, and where we'll start to engage these filters, is about the consistency of things. So the little arrows that they give you at the top on Excel when you filter things, the little drop downs, are really great for getting a sense of what are all the values that exist. So in this, we're talking about a 30-row data set. You could probably just go through it manually and figure out more or less whether the data was consistent. But if you had, say, a 3,000-line data set, it becomes a lot more difficult to do that. And the ability to open this up and go, well, that's interesting. There's like 4 entries that are subtly different for Atlantic salmon. What's up with that? And in this case, that one's got an extra space in there. I'm not 100% sure this one is. It might be an extra space at the end or something. That one, they've thrown this little cross in here, which I'm sure denoted something, but I don't know if they actually told us what it was. Why that Atlantic salmon is different from the other ones. But that's the sort of thing where now if you run this and you're trying to put that in, say, a pie chart or a bar chart or anything like that, you're going to end up with a different segment for each of these because they're not actually the same, because the text in them is slightly different. And that's something that can be easily cleaned up, either manually or with a tool like OpenRefine, and then you won't have that problem anymore. But the first thing you have to do that is A, identify them, and B, determine whether or not it's a good idea to fix them. For something like this, yeah, probably those are typos, right? They're little extra spaces, not a big deal. This one with the cross, you might take a second and go, well, let's figure out what that cross meant and whether that really is significant information before we just clean it up for the sake of cleaning it. Other ones, so this jumps out, of course, in the number of fish that escaped Gollum. They basically just did an estimate, which is, I guess, fine. I mean, estimating speaks to that correctness question, but because of the way Excel treats something like this, it doesn't know how to handle a range. You can't do an average or statistical analyses on a range. It's just going to treat this as text, basically. Or God forbid, like a mathematical formula and give you a negative 100 fish escaped. So those are the sorts of things that you go through and you go, okay, well, how are we going to treat this? Do we take the middle of those values? Do we take the high? Do we take the low? ideally, you kind of go back to wherever this was submitted and make it very clear that they need to provide one specific number. If it's an estimate, then just pick one number as the estimate. And then you kind of leave it up to the person who knows best, which is the person who is providing the data, what is the best choice to pick in that 200 to 300 range, which is going to be the closest. There was also an interesting one. In this cause thing, as I say, it seems very clear to me that they like we're using some sort of controlled vocabulary just because it's too consistent, until we get to this one, where they have this extra note, which doesn't even actually belong in this column. It should be over in like the comments section, but I don't understand how it ended up in this one. Again, in terms of fixing it, not a big deal. You just recognize, okay, we have a column section or a comment section anyways. We can copy that and paste it over and clear out and just have the cause event be what we'd expect it to be. In terms of how that happened, it's the sort of thing where you might dive into, okay, what does the form look at like that people are submitting this on? Did something go wrong in the data submit where these got combined? Was it like a computer error? Trying to figure out what happened and how to prevent it is also, as important as fixing it, because you can fix it for this one example, but then if it happens the next time someone submits something and the next time and the next time, you've kind of just backed yourself into a corner where you can be constantly checking it, fixing it, checking it, fixing it, checking it, fixing it, rather than going to the more systemic, let's stop it from happening in the first place. So yeah, that's sort of just a quick overview, very small example to kind of reinforce the things that we went over in the presentation and give you a concrete, okay, here's what this actually looks like if you're looking at some data. If anyone has any questions or comments on that, other things that you're seeing, I'm going to open the floor now and hopefully we get some people who want to talk. And if not, stop sharing here. If not, then I'm just reading through some of the comments, sorry. The GIS disaster, yes. All right, so the two comments people aren't reading them are, yes, the GIS disaster, between the NAs, which a GIS is just not going to know what to do with, and two of them showing up in completely the wrong place in the world, that would definitely be a problem. Yeah, the idea of giving people extra space, like a comment field, or like an other, especially if you have like multiple, here's, a general other and a more specific other and a different, more specific other to a different aspect. Like, it's good to give people a space to put in information. It's never going to be a complete thing. Like you're never going to get people consistently putting in the same sorts of comments such that it looks complete. But sometimes a null field kind of is the correct answer. Sometimes there just isn't any information to give people.
I have a comment about the comment, a meta comment, if you will. It speaks to your earlier discussion or mention of like keeping an eye on things and changing things as needed, that if there's somebody kind of curating this data set and finds that people keep using the comment field for a certain field, then their job is to go back and add a new field so that people stop putting valuable information in the comments. Add a more uniform field. If people start talking in there about whatever, it'll be so dependent on the subject, but you know what I mean.
Yes, excellent point. No, absolutely. And that's one of those added value things where you may not have realized when you were setting up a form or starting to collect data that a particular aspect of it would be significant to people or would come up a lot. And like, you only ever want richer data, right? So if people are willing to give that information, they're going out of their way to give it to you, then by all means take it, like try and get it more consistent.
Does that create a challenge in terms of the data that you've collected prior to making that change to your data collection system?
It's definitely one of the things that can result in holes. You can go back clearly and move the data for the sort of, if a few people did put in a comment, you could just shift that over. But unless it's the sort of thing where people are going back and checking a profile and updating their own data, then they might fill it in after the fact. If it wasn't there originally, you might just not have it for some people. And that's where you just sort of note that, just record it in metadata somewhere of this is how this has changed over time. And this is why, you know, prior to August 2020, we didn't have this field. So we weren't asking this question. And that's why those ones don't have that. So I don't know if our participants have anything in particular that they're working on that they'd like to look at specifically.
Yeah, and if that's not the case, then then I guess we can wrap up at this point. Is that right, Sarah?
Yeah, I mean, it's sort of up to what people want to do. Like, I can keep pulling up data sets and pointing out things in the same sort of way, but I don't know that that's watching me on the fly try to assess data is not necessarily like good presentation material. It's be more like a job interview test or something. I don't really know. I don't think it's going to necessarily be that helpful.
Yeah, no, let's just, I guess we have, yeah, Christina and Sarah and Matthew. So it's just in case if any of you three have a specific request or question, then bring it up now, I guess.
There's a question in the comments now. So yeah, OpenRefine is good. I work a lot in databases, so I tend to just end up writing my own programs to clean things, or just using the sort of built-in tools in MySQL or things like that. Excel, like most data ultimately can be opened in either, say, a Word doc, right, if it's like a big text type thing, or hopefully in like a CSV Excel type format. If it's not kind of natively in that, you can usually get it to open in something like those tools, just to move it around. And Excel offers quite a bit of things. So the filtering, being able to kind of very quickly look down and see what are the range of values, how many are there, are they all numbers, are they all words, that sort of thing. And then within that, they have a lot of find and replace tools, or a lot of the functions that they offer, if you kind of move off the page, will help you clean things up. And there's a lot of great tutorials on the web for using Excel in those ways. It's one of those things there's so much that Excel is doing that it's difficult to understand how much it does until you start digging into like tutorials of how do you data clean? How do I convert all of these files? How do I, like things like VLOOKUP. So for example, if you wanted to suddenly add a column to that data set that gave more of a place name, like here's the closest city or something. If you can find a table that lists the closest city by the latitude and longitude, then you could add that by just kind of doing a VLOOKUP that said, okay, I want you to take the latitude column and I want you to look up whatever's the closest in that thing and give me back the city name. That would be a complicated example of that, but like just working in basic tools that that are either free or that everyone has usually access to if you're working in an office environment, kind of keeps things simple and means that you're not having to, you're not putting out a lot of money, and you don't want to become the bottleneck for cleaning data. If you sort of are investing in like some power tools that will do things like this, but you only have one license to it, you become the person who has to do all of it. Anybody who has data that needs cleaned is going to end up pushing it across your desk because you're the one who has it. If that makes some sense.
Sarah, if you completed, sorry, was that the end of your answer? Because I was just going to bring your attention to another question from Sarah Jenkins.
Yeah, well, there was the second half of that question. The larger data sets you can't scan visually.
Yeah. Oh yeah.
If even first. Like clicking on a filter kind of gives you too many values you can't really tell, or those sorts of things. If your intention is to put it in a particular type of chart or do a particular type of analysis, you kind of know what your intention is to do with the data. Doing like a really quick sloppy version of that and seeing how many fields you're getting, or seeing like, oh wow, I got an extra column for that's like super tiny and clearly only has one value but has a really weird label. That kind of lets you, like, you can't see all of the data, but you will see the most wrong data by just throwing it into a chart if that is something that you're intending to do with it, like that type of analysis. Just do that early, pick out those things that are wrong, and then you can kind of like knock out the lowest hanging fruit the fastest, if that makes sense. Yeah, okay, second was, yes, versions of data set. Labeling your raw data sets, like having a conception of what is the most raw data, is probably the most important one. Like having that clearly labeled as here's the data that came in and nothing has been done to it whatsoever. So that you can always find that one again. If you are processing or cleaning that in multiple ways so that you're ending up with a lot of different versions, I would say the two, yeah, right, protecting, yes, excellent. As long as you don't intend to change it, yes, yes, yes. Dating any versions that you're making, so that you kind of know that this is the one that was made at this point, will give you a kind of reference so that if you ever have a note that like, oh, in 2020, someone pointed out that this was wrong, so going forward, we've changed that. But if you have an earlier version, it might still be wrong in there. Here's our expiration dates so that you know that this data set hasn't been touched in a long time, and then being able to compare that against the versions. Just having a date attached to any, either in the file name or just in the metadata attached to it is, I think, very important. And then ideally, if there's a way to attach metadata to it, which like, even if it's just sitting on your hard drive, there is ways, certainly in Mac, to attach notes to files. I'm actually not completely sure on Windows if there is or not. That might be a question for someone else if anyone works a lot in Windows. Anyway, you can kind of attach additional metadata to most files on computers anyways. And just sort of having a note of like, here's this quick step-by-steps of the processing that was done, just literally attached to the file, make sure that that's not going to go missing in any way.
Sarah, as a, not a data manager, but someone who works with data analytics and machine learning, have you seen any examples of, I guess, machine learning applied to uncover issues with data? So sort of in an unsupervised manner of, kind of identify potentially things that don't fit the pattern or something like that. It's kind of very broadly formulated, my question, but I was just curious.
I see what you're saying. I've seen definitely some blended things. So even like OpenRefine will try and do it to a degree. It tries to be a bit smart and will try to point out data that doesn't match the rest of it and be like, hey, what if we fixed it this way? Yeah. I feel like most of the models I've seen where people are trying to rely exclusively on AI or machine learning to manage data, whether you're cleaning it or deleting bad data or things like that, it's the biases in the algorithms, right? So things like YouTube tries to do that to a degree to help them handle their like copyright complaints or things like that, to stay ahead of people complaining about either the videos that are being posted being offensive in some way or that it's stolen material. And they end up hitting nothing but problems with it because, well, what's an offensive topic? Someone has to decide that. And I mean, for me personally, like as a member of the LGBT community, they tend to block a lot of that stuff. So for example, a school that installs like a YouTube generic blocker to block out any offensive material will end up blocking any queer related material, just because that's what YouTube's algorithm considers offensive. And on the other side of things, if the way that it detects copyrighted material is like basically if there's more than a 3-second clip of a movie that or something that a production company has like flagged as like, this is our property, it will pull it down. But that could be a 3-second clip that someone has like taken out and edited in because they're commenting on it and they're doing their own voiceover over top of it because they're talking about the movie and whether it was good or not. And it's not, it's not like they've put the B movie online again. They're not stealing it. They are trying to do their own thing, but referencing it. but YouTube will end up pulling it down just because all they care about is like, hey, here's 3 seconds of a clip of a film that the production company has said is theirs. We've compared it and it's the same, so we're going to pull your thing down. If there's not a human involved at some point along the line, those things are going to go wrong. And you're going to, depending on what you're trying to do, if your goal is just to create a list of things that a human should then check, that's probably fine. If you're going to have the machine cleaning and deleting things on its own, that's a big problem if it's having false negatives or just catching things that it doesn't need to be catching.
That makes a great deal of sense. Thank you. Yeah, Christina is saying that
no one is too good for Excel.
Yeah,
Excel is great.
I agree with that one too. Even though you know, as a Linux programmer kind of person, I guess I can come across as a snob in that respect. I do use Excel from time to time. It is handy when all you want to do is just really quickly look at something. The other comment, Sarah, sorry, was I suppose there is also a lot of strength to, if you do have a large data set, then to randomly, you know, like, you know how what's the English term for that? When you just kind of go out and sample a few to see if they're right or wrong, if there's any issues. I would imagine that with a little bit of sampling, you could, you know, at least at some statistical level, you could quite quickly get to the point where you would claim that because I've selected these instances randomly and they were all fine, then with this much confidence, or, you know, 99% of the data set should be fine, or something like that. Like, I think you could even, in a statistical sense, make some statement about, based on a small number of checks, how solid this data set is. I don't know if that's something that's being used too, or do you know what I mean?
I saw a museum once that was tracking kind of statistically the completeness of their metadata in that kind of a way.
Right. Yeah.
The problem is they would have done it by like any field that's blank counts as a 0, but if there's no value to go in that field, it's not a 0 really. It's just like an actual null value.
Well, thanks you for addressing my questions. I've exhausted my list of questions here.
Yeah.
So I'd say, unless Sarah and I think, yeah, and Christina have any additional questions, Sarah's saying thank you. So I think we're at the end here. We can wrap up. Is that okay with you, Sarah?
Yep. Yep.
Yep. Okay. Well, thanks, Sarah, Christina, Matthew, for participating. And also thanks for watching, those of you who may be watching this at a later time. I think the only thing that's left for me to say at this point is that we will be uploading this, we've recorded this webinar, we'll be uploading it to our YouTube channel. So you can go there and watch it at a later time. Yeah, with that, I'd just like to thank you all again for your participation, and thank you, Sarah, for running this very nice webinar.
No problem.